So yesterday we started our unit on systems of equations. If you were absent, you missed the graphing lesson, which is the easiest one. Okay? What we learned is that when you graph two lines, so I'm just going to do a picture. Y'all don't need to draw anything or do anything. If I graph a line here and I graph another line here, where they meet is called what? Solution. The solution. So this is the solution. The answer is written as a coordinate, an x, comma, y. So let's say this is at -2, +4. I freehanded it so it's not like accurate, but that would be my answer. Are y'all with me? Because that is where they meet. This point right here satisfies both equations because it falls on both lines. Are y'all with me? Yesterday we learned how to solve systems of equations by graphing. So you would graph it, and where they meet is called the solution. Today we're going to be given two equations. So look at the first example. I have this equation and I have this equation. And it wants to know what, if I was to graph these, where would they meet? What is the solution? But you don't get to graph it. Yes? So I'm going to teach you the first method today without graphing, and it is called substitution. I think it ends up being most students' favorite way to solve without graphing. It's the way I remembered from Algebra 1, without teaching algebra, because now, of course, I remember all the ways, but when I was 10 years out of college and I had to solve something, this is the way I actually remembered how to do it. It is not hard, but it's a process, okay? Your first step, so I want you to write this up here. Your first step is to isolate a variable for one equation. It might already be done for you, but if it's not, you need to isolate a variable for one of the equations. What does that mean, to isolate a variable? Isolate. If I isolated you, what would I be doing? Put you by yourself. So if you look at this example, we have an equation here and an equation here. Is y already isolated over here? It says y equals something. Then we don't have to do this step. It's done for us. Are y'all with me? Your second step is to plug in the isolated variables equation to the other equation. That sounds confusing, but it will totally make sense in a minute. So, basically, you have two equations. This one is telling you the value of y is what? So you're going to take this equation, and over here where it says y, you're going to put what instead? 4x, because this is telling you y is. So over here, instead of having y, I'm going to put 4x. So we're going to go do that. So over here, I'm going to say 3x minus, and I'm going to plug in what they told me y is. What is y?
4x.
Equals 1. Now I want y'all to think about this. Do I now have an equation with only one variable?
Yes.
Can I solve for x? Yes. You can always solve for a variable if you just have one variable. So I'm going to solve this equation. What is 3x minus 4x?
1.
Negative 1x equals 1. All right, how would I solve for x here? Divide by negative 1. And what do you get x to be? You just found, what should our answer look like? X, comma, y. We just found the what? The x. So we know part of our answer. Are y'all with me? So I know my x. I now need to solve for the what? The y. Because my answer, guys, your answer should be an x, comma, y. It is the point where both the lines do what? Meet. So they meet, their x value where they meet is -1. So can I now take this x value and plug it in for x and solve for y? So y is equal to 4 times the x value, which is -1. So what is y equal to? Do I now have the coordinate to write as my solution? Yes. So what is the x value? -1. What is the y value? -4. If I was to graph this equation and then graph this equation, they would meet at -1, -4. Are y'all with me? Yes or no? Okay, I'm going to say this again. This is called substitution because we took this equation and substituted it in over here for the y. Do y'all see why it's called substitution? Yes or no? All right, let's do the next one. What is our first step? Take one equation and isolate a variable. Did it say which variable? So look at this one. Is a variable already isolated? What is isolated? X. So I know that x is equal to what? So over in this equation, instead of x, right there, can I plug in 2y? All right, I'm going to substitute in. So I have y equals, instead of x, what am I going to write? 2y minus 2. Do I now have an equation that has all the same variables that I can solve for the value? How would I get all the y's to one side? Can I pull this 2y over here? Could I pull this y over here? Does it matter which way I do it? No, I'm going to go ahead and pull this 2y over here just because this -2 needs to be moved away from it anyways, right? So I'm going to subtract 2y. That cancels out. Now, what coefficient is in front of this y? What is 1 minus 2? -1y equals, what do I bring down here? -2. How do I get rid of a coefficient of -1? Divide by -1, and I'm left with y equals +2. I have solved for part of the solution. I now need to solve for what? X. And you can plug this in to either equation. It doesn't matter. I'm going to plug for this one because it says x equals. So x equals 2 times the value of y. What is y? 2. What is 2 times 2? Do I now have both parts of the coordinate? So my final answer is 4, 2. Again, if I graphed this equation and then I graphed this equation, they would be two lines that would meet. Where would they meet at? 4, 2. What do y'all think so far? It's really not that bad. Okay? Let's try this one. Do y'all want to try it on your own? Just to see? Okay, let me talk to y'all through it first. Is this equation already isolated for a variable? Look at it. It either needs to say x equals or it needs to say y equals. It doesn't matter which one it is. It just can't be like 2x equals. So yes, you're going to go plug this in for what? X. Everybody should be doing it. Did everybody solve for y yet? Are y'all still solving for y? If you solve for y, I'm going to go do that right now. Instead of putting x here, this says x equals. So I'm going to go take this x away since I know that x equals 2y minus 3. So I plugged this in for this. Are y'all with me? Plus y equals 3. I'm just going to erase that underline. I was just showing y'all what I did. Did everybody get that far? Can I combine like terms on the left? What coefficient is in front of this y? What is 2y plus 1y? So I have 3y minus 3 equals 3. Yes? How do I get rid of the minus 3? Plus 3. I have 3y equals 6. How do I get rid of the coefficient 3? Divide by 3. And I'm left with y equals 2. To make a coordinate, what else do I need? I need an x. So I'm going to take this y and plug it back in for this so that I can solve for x. So I'm substituting here, and I'm substituting again. Yes? So I'm going to plug y in for 2 in for y. So I have x equals 2 times y. What is y? 2 minus 3. So x equals what's 2 times 2? What is 4 minus 3? So what is my answer? 1, 2. Now I want y'all to look at the next example. Are either of the equations isolated for one variable? No. So I am going to have to do step 1. Isolate a variable for one equation. Does it matter which equation you pick? No. I'm going to look at it and pick the easiest one. And they both look easy to me. I'm going to do this one because I can easily get rid of what right here? The 2y. Yes, and have x by itself. Are y'all with me? All right, so here we go. How do I get rid of minus 2y? Plus 2y. So this is gone, and I'm left with x equals 2y minus 1. This is now the equation that I use. This equation and this equation. Do y'all want to try the next step from here? Y'all should be able to do the next step without me by now. What am I going to plug in for x over here? 2y minus 1. Go plug it in. Everybody should be doing it. I'm going to say it again. If you're confused, look at the board. I know that x equals 2y minus 1. So over here for x, I'm going to replace this x with 2y minus 1. Did you get it? Now, for those of you who are struggling to solve equations, could you solve this equation in your calculator? You put this in y1, this in y2, second trace, option 5, enter, enter, enter. Yes? Okay. But we shouldn't be struggling with equations. We've been doing them all year. Okay, but if you are, you can do that. All right, so I'm going to combine like terms. What's a negative 1 plus 4? Plus 3. And I'm going to subtract 2y. I have 1y equals 3. Well, that's just y equals 3.
I combined it 3 and 9. 3 and 2.
You have to move it to the left by subtracting. Remember, they're on different sides of the equal sign, so to move it, I have to do the opposite operation. Okay, what do I do to get x now? I need to take this y and plug it in over here for that y so that I can solve for x. So x is equal to 2 times y, which is 3, minus 1. So x is equal to, what is 2 times 3?
6.
And what is 6 minus 1? So x is equal to 5. So what would my answer be? 5, comma, 3. Okay, flip to the back. What is the first thing we have to do? Isolate one of the equations for a variable. Which equation looks easier to isolate? I need everybody paying attention. This one or this one? The first one. Why? Because both of these have coefficients. That's going to take an extra step. So I definitely want to do this one. How am I going to get this x by itself? How am I going to get the x by itself? Minus 2y. So x is equal to negative 2y plus 0, which do I even need to write that? No. This is now the equation I'm going to use. And I'm going to take this x and I'm going to plug in negative 2y for that x. Now I need y'all to listen to this part. I need everybody to listen. If the x over here or the y over here, whatever you're substituting in for, has a coefficient, you need to put this in parentheses. Make sense? Because you'll have to distribute. So I say 3 parentheses times whatever x is. What is x? Negative 2y plus 4y equals 4. I have a lot of daydreaming going on, guys. You do not want to daydream on this lesson. It is a very important lesson. So I have negative 6y plus 4y equals 4. What is negative 6 plus 4? So I have negative 2y equals 4. How do I get rid of the negative 2? Divide both by negative 2, and I'm left with y equals negative 2. Now what do?
You plug negative 2 in.
I take this negative 2 and plug it in for that y. I can't plug it in for x when it's y, so that I can get x, yes? So x is equal to negative 2 times negative 2. What's negative 2 times negative 2? So what's my answer? 4, comma, negative 2. All right, I want y'all to try the next one on your own. Is the first step already done for you? Yes. Remember what I said. Does this x have a coefficient in front of it? So you have to put this in what? Parentheses. You can check your first step with mine if you need to. Once you've solved for y, check it with mine. Did we get the y correct? Awesome. Now we're going to take the y, plug it back in for this y so we can solve for x. X is equal to 4 times y, which is 2, minus 1. So x is equal to 8 minus 1, so x is equal to 7. My answer is 7, 2. Are there any questions so far? All right, moving down. What would be my first step on this one? Isolate an equation. Which equation is going to be easier to isolate? Why? Why would I not want to do this one?
Because I have one.
They both have coefficients, which means I would have to do an extra step. Is that okay if you want to do the extra step? Sure. I'm not going to. I'm going to pick the easier one. Let's solve for x. X equals 16 minus y, or x equals negative y plus 16. Yes? Are they the same thing? All right. I'm going to come over here, and I'm going to plug this in for x. Do I have to put it in parentheses? Yes. Why? Because this x has a coefficient. So I have 3y equals negative 2 times the value of x, which is 16 minus y. So I have 3y equals, and I need to do distributive property first. What is negative 2 times positive 16? Negative 32. What is negative 2 times negative y? Positive 2y. And then plus 2. Can I combine like terms right here? So I have 3y equals what's negative 32 plus 2? Negative 30 plus 2y. How do I get this 2y over here with this y? Minus 2y. 3 minus 2 is 1. So I'm just going to put y equals negative 30. So I'm going to plug this y back in for this y. So x equals 16 minus, now this is a part that's confusing, everybody look. Do y'all see where I got x equals 16 minus? Now I plug in the value of y, which is negative 30. So it's a double negative, right? So keep change, and it's plus. So x equals 46. So my answer is 46, comma, negative 30. Can you get big numbers? Absolutely. Now we're going to do a real life situation that you would actually use this in. Okay? Here we go. How many equations do you think we're going to have to write? 2. Why? We're doing systems of equations. Here we go. At an ice cream parlor, ice cream cones cost $1.10 and sundaes cost $2.35. One day, the receipts for a total of 172 cones and sundaes were $294.20. How many cones were sold? I need 2 equations. Okay, and it's going to take a lot of practice for y'all to get used to writing these, and that's okay. This is our first one, so don't freak out if you're struggling. I want your first equation to be about the money. Okay, what are we talking about? Sundaes and, okay, so let's call cones C and sundaes what? S. Who can write me an equation about money, and it is in standard form? I'm ready.
$1.10 C plus $2.35 S equals $2.94.
Does everybody agree with that equation? Cones are $1.10 per cone. Sundaes are $2.35 per sundae, and their bill added up to equal $294.20. Are we good? Now we need an equation for the total they sold. Does anybody think they can do it? How many did they sell total? You got it? Don't overthink it. It's going to be in standard form. No, we already did money. So I'm done with money. I just want to talk about this number right here. They sold a total of 172 cones and sundaes.
C plus S equals 1.
Perfect. Their cones plus their sundaes sold were equal to 172. Do y'all see where we got that from? They want to know how many cones were sold. Did they ask for cones and sundaes? So all I want to solve for is the cones. Yes? What is my first job? Take one of the equations and isolate a variable. Are y'all good? Which one looks easier to isolate? Definitely this one. Okay? If I solve for C, which one do y'all want to solve for? C or S?
C.
Okay. So C is equal to 172 minus S. Do y'all see what y'all just did though? The question asked for what? Cones. But we're going to use this and plug in for that, and we're going to end up solving for S. So would that one be more beneficial, or would solving for S be more beneficial? S. Doesn't matter though. Okay, but I want to do it easier. So I'm going to solve for S. S equals 172 minus C. So I'm going to take this and plug it in for that S. Yes or no? All right, so here we go. 1.10C plus 235, open parentheses. What am I plugging in?
472 minus C.
Equals 294.20. Could I plug this in my calculator and let the calculator do it? Y'all want to do that? Okay, just for a refresher on how to use the calculator. Go to your windows and check them. Mine has been reset to factory settings. So they're set from -10 to +10. I definitely probably want to make it bigger. So I'm going to change it to -500 to +500. What am I setting? The minimum and the maximum. I'm also going to set the Y minimum to the same thing and the Y maximum to the same thing. The minimum's always the negative. The maximum's always the positive. All right, I go to Y equals. I put in the left side of the equal sign. So 1.10x plus 2.35 open parentheses, 172 minus x, close parentheses. For Y2, I put in the right side of the equal sign, 294.20. All right, where do I go? Option?
4, 5.
Look at them. 5. I want the intersection, right? Enter, enter, enter. What's the answer? 88 what? What did we just solve for? C, and what did C represent? 88 cones. Did it ask for cones? What if it asked for sundaes? What would I do? Plug this in for C, and 172 minus 88 is 84. There would have been 84 sundaes. They did not ask for that, but I'm just showing y'all just in case. The directions, please. On 1 through 6, does it say solve the system, or does it just say solve for the indicated variable? So on number 1, what are you going to solve for? So you're going to solve for that y. On number 2, you're solving for y. On number 3, you're solving for x. You're not solving a system. They're basically teaching you step 1. Yes? All right, 7 through 12 does not say solve. It says circle the equation you would use to isolate the variable. You don't have to explain your reasoning, but there is a wrong and a right answer. Number 7, obviously, which one would I circle? Which one would you use? Why? It's already done. You see what I'm saying? So if you circle this one, it's clearly wrong. You would not, it's saying basically circle the one that would do the less work for you, would be easiest. All right, 13 through 18, you are going to solve the linear system by substitution. So that's literally what we just learned. You are going to omit number 15 and 18. So mark out 15, mark out 18. You are going to do the word problem. Look at number 19. Did they write the equation for you? So literally you're just solving the system. And number 21, it's going to make you do it yourself like we just did, but it walks you through each step. Okay? All right, you may get started.